There were some pears and apples in a box. If 4 pears were taken out from the box, there would be an equal number of pears and apples in the box. If 7 pears were taken out from the box, there would be four fifths as many pears as apples in the box. And we'll ask how many apples were there in the box at first and how many pears in the box at first. Okay, I'm just going to draw this exactly as I approached it when I looked at it first, which was just a couple of minutes ago. Okay, so we've got pears and we've got apples. And we have a point when there are an equal number of pears and apples. And that's the bit that drew my attention as to be where I would start. So we've got pears and we've got apples. We are comparing quantities, so we definitely want sort of separate blocks. And at some point, we have equal amount, we have an equal number of pears and apples. So this is my sort of start point for my model. Okay. Now, what does it tell us? It says that if 4 pears were taken out, there would be an equal number of pears and apples. Okay, so there must have been, 4 additional apples. All right, so let's see if this works. If this is the pears, and this is where pears and apples are equal. If 4 pears were taken out, if those are removed, they're an equal number. Yes, that works. This represents that. However, it also says if 7 pears were taken out from the box, there would be 4 fifths as many pears as apples. So if, as well as this 4, you took out an additional 3 apples, why 3? Because 4 and 3 are 7. Okay. If you took out 7 apples, then there would be 4 fifths as many pears as apples in the box. What does this mean? This means that if this were divided into 5 equal parts, the pears would have 4 of those parts. I'm going to use another color just to help me here. So I'm going to divide this into 4. These are the 4 fifths. Okay. And, it's just worked out, thankfully. So we go 1, 2, 3, 4. And it wouldn't have mattered if the size was out, as long as you should be able to see that the difference, must be this difference of 3 must be equal to a fifth. Okay, because if 7 were taken out, this would be the end of the pears. This is the end of the apples. We know that at this point they were equal. And if you take out an additional 3, you end up with the pears having 1/5 less. So this must be equal to 3, as must all of these other parts. Okay. So it looks really tricky, but if you just take your time and think about it, I think it becomes quite easy. In the textbook answer, they sort of redraw it a second model down below. I just don't think you need to do that. And I think, to be honest, it's for me, certainly it's easier to visualize just on the one model. Right. Well, we've got numbers for everything now, so we must be able to answer the questions. So how many apples were there in the box at first? Well, that's all of this amount, because it says if these, it says if 4 pears were taken out, it doesn't say that they are, so it must be including all of these, and it's how many pairs were there in the box at first. Okay, well, we don't lose any of those. So let's look at the apples first. So what have we got? 1, 2, 3, 4, 5. We've got 5 times 3. Nice and easy. So that's 15 apples. Okay, all right, so how many apples? 15. And how many pairs were there in the box at first? Well, we have got 15, haven't we? All right, because if this is 15, so is this, plus an additional 4. So this is just 15 plus 4, which is 19 apples. Okay, I think in the textbook they I don't know why they decided to multiply these all again, but actually probably because they did the 2 separate models. When you do it on the one model, it's just really easy to see, isn't it, that this is 15, which you know because you've calculated this, plus the 4. So the answer is 19.